Hi guys, welcome back to another session on second order differential equations. Today we're going to be looking at continuing with our last video, non-homogeneous type equations, and in particular when those functions are some sort of exponential form. Notice I always start my answers by stating the standard form of equations that we are going to solve using this method. And that's because I want you guys to be able to identify clearly what your standard equation should look like, what format it should take before you are able to apply the following steps. Because there are many different types of differential equations out there. Also, on a point to note, I'd like to say that I have been receiving some comments about the volume variations in my videos, and it's because I am trying my best to teach amidst the conditions of external noises in my environment, and it is difficult. And I want to say to students listening out there that I know sometimes your situation may not be one where you have everything you need to use. Some students may have a simple calculator, some may have that scientific calculator. Similarly, I am just human and I do not have the best of both worlds. I do not have the best features, the best software, the best room. But what I do know is that at the end of the day, I give the best of myself to you guys, and I'm trying. And I hope that you can appreciate my efforts. Trying to my best. My intention is to reach those students who have some form of internet access, but very irregularly, and they can't get into classes when they should be able to during the typical 8 to 2 period of the day, during a typical school day with their teachers online, but somehow random times their internet picks up and they wish they had some sort of learning to take place then. So these videos are really catered towards those students. Some of my students who also have those issues, they very happy that they can access these videos when the need arises. And also, they do not essentially have to, come up with funding to be able to afford a private tutor. You know that extra classes can be quite expensive in these very difficult times. So I am trying my best to provide as best quality as possible to you what I can. Also, I will be editing a lot of my videos as soon as I am able to get a device that belongs to myself. I'm currently using a device that is not even mine. So I cannot install software until for the editing purposes. I know some of my videos have small errors. I multiply 2 by 2 and I get 2, and I can't edit them out. My videos, I can put in a comment, I can put in a nice pop-up, and hopefully when I get my new device soon, I'll be able to do so. So I'm sorry to have a little bit of a rant in the middle of the video. For those of you watching, you can just fast forward to let's just say 3 or 4 minutes later. But guys, you can see that teachers are just human, just like you. And I do appreciate all the comments and I do respect it because, I mean, when I'm watching videos too, I would like the best quality. So bear with me and remember, this is for a good cause. You guys are just, wanting those extra classes. So nevertheless, let's move on to today to differential equations. And once again, we'll be looking at second order differential equations where we have that right hand side not being equal to 0 and it's of a exponential form. Sorry. So on screen here we have let's see, we have an equation and we can create the auxiliary equation for this. So creating our auxiliary equation will give us m squared minus 3m plus 2 is equal to 0. Now, I'll just tell you that the solutions to this are given by our complementary function. Y is equal to a e to the 2x plus b e to the x. We have done many examples like these, so please be sure to review some videos where it shows you how to get your roots to this auxiliary equation and how to develop your complementary function. Today we are actually interested in that particular integral and what it's going to look like. So for this question, our particular integral for any type of exponential function should essentially take the form y is equal to lambda e to the whatever power we have been given in our right-hand side. I'll call that alpha. Now, in this question, on our right-hand side, our value that the exponential function is being raised to is 2x. So therefore, I can replace my alpha with a value of 2. And that's our particular integral. Now, there's something quite concerning about this particular integral for this particular question. And that is that if you compare your complementary function, one of the terms is very similar to your particular integral. And in cases like this, where your particular integral is almost identical to one of the terms in your complementary function, then you need to alter your particular integral by including an element of x. So a particular integral for this question would be lambda x. Take note, this is only done in cases where we have the exact same particular integral being present in our complementary function, and that is something we cannot have. So using our newly recreated, readjusted particular integral, we are going to continue with our process of differentiating. Now, differentiating a first time, we are going to get dy dx is equal to, I believe, lambda e to the 2x plus 2 lambda x. I'm doing this in my head, so we'll double check in a bit. So you can identify that this particular integral is actually of the form where we will have to use some form of our product rule in order to differentiate. And I have decided to let my u be equal to lambda x and my v be equal to e to the 2x, such that I have my u function being present here, and I differentiated my v to get 2e to the 2x. Also, I have my v present here, and I differentiated my u to get lambda. So this requires use of the product rule. Okay, so after differentiating a first time, this is a second order differential equation. So we do need to achieve a value for d2y dx squared. And of course, here you will see that we have to use the product rule again. You can take your time and you can pause this video and you can use the product rule to differentiate the second term. But I'm going to get straight into the answer. After differentiating, you should arrive at a solution of 4 lambda e to the 2x plus 4 lambda x e to the 2x. All right, so after we have finally gotten values for dy dx and d2y dx squared. Now what we need to do is substitute these values into our original equation. Now, this is going to give us a very, very, very long equation. We will get 4 lambda e to the 2x plus 4 lambda xe to the 2x minus 3 lambda e to 3 2x minus 6 lambda xe to the 2x plus 2 lambda xe to the 2x being all equal to e to the 2x, which was the right hand side of our original equation. What you can do here, you can equate some of your coefficients. You can choose to equate the coefficient of the right hand side of the exponential form, which is 1. You can equate that on your left hand side. You have coefficients of e to the x. You can choose to equate to those. And you should end up getting a value where I'll just simplify it here. You get something of the form lambda e to the 2x is equal to e to the 2x. Therefore, you would get that lambda is equal to 1. So take note that e to the x did not contain any values of x in front. So if you're equating coefficients, the ones that you can equate to this would only be that 4 lambda minus 3 lambda, which gives us lambda. This as well is in terms of x. All right, so that's one thing you could have done to generate the value, or if you wanted, you could have chosen to equate these coefficients, which are not present on your right hand side, and you can equate them to 0. Make sure that when you are choosing which coefficients you're comparing and equating, you choose the ones that are easiest to work with. All right, so now that we have a value for lambda, we can safely rewrite our particular integral as being equal to y. Remember, our particular integral was lambda x e to the 2x. That presence of x is only there because you cannot have your particular integral being the same as part of your complementary function. Generally, rule of thumb, your particular integral for exponential functions is given by lambda e to the 2x. And this would be wise to take note of. So in this question, we found lambda to be 1. So replacing that value with 1 just gives us xe to the 2x. Finally, putting our answer together, we will arrive at a solution. Our general solution is given by y is equal to our complementary function, which earlier was ae to the 2x plus be to the x, and then our particular integral, which we have filtered down to be equal to x e to the 2x. And there you have it. That's how you would find a general solution for our non-homogeneous second order differential equations, where your functions given on your right hand side are of the exponential form. Take note that this is your particular integral that you would use, and if your particular integral happens to be part or exactly the same as one of your terms in your complementary function, excluding the constant value of lambda, of course, then you need to introduce an x so that your particular integral is a bit different. If you guys would like to see more examples of the exponential type, because it does get a bit tricky sometimes, be sure to message me down below, leave a comment. Those of you who have me on WhatsApp, you can be sure to message and ask for more tutorials on this. And I think that's the end of our sessions on differential equations. Be sure to look out for any videos that students may request to assist them in completing their modules. And guys, please remember that try your best. You must put in the effort. The effort cannot be one time. You must practice sufficiently. I know there are a lot of students who reserve one full week to memorize an entire year worth of pure mathematics. And it may be possible, but it's not very wise to do so because your brain gets overloaded through the cramming process and it becomes so tired when you do exams, you will end up blanking out. You need to be able to retrieve your memory that's been present over a period of months. So it's always best when you are revising maths to touch a little bit of it, even if you can't every single day. You touch a little bit of it, you reserve 2 hours twice a week or so, and your mind builds its capacity and its ability to remember. And the next time you see questions like this, you'll notice that it suddenly becomes clear and so much easier. So if you decide to take my advice, I am super happy about that. If you don't, I still hope you guys are able to pull on a lighter and still do well. So I wish you success in your endeavors, no matter however you try. Okay, guys, so thank you for watching and be sure to share my videos with anyone you know needs the help. And I appreciate it very much. Thank you and see you guys next time. Bye.